Welcome to the deep dive. Today we're digging into some pretty technical source material you sent us. It's the documentation for the Thor broadcast, F-8A-RCA-TxRx.
Which is basically an 8-channel audio over fiber kit.
Exactly. And our mission today is to figure out the genius behind it. How do you send crystal clear, professional-grade audio over, well, kilometers without it degrading into a humming mess?
I think the first question people have is always, why even switch from copper? And the core benefit, really, it isn't just distance. It's about preserving the signal quality perfectly.
Okay.
We're talking about converting line-level audio, that's the strong Signal Pro gear uses, and then sending it up to 20 kilometers without any expensive, bulky, shielded copper wire. The savings on just the cable can be massive.
That makes total sense for a permanent installation.
Right.
But the source material calls it a simple audio to fiber converter. So what's the biggest catch when you move from analog copper to, light? Is fiber more fragile?
That's a great question, and it used to be a huge concern. But modern fiber is actually really robust. The complexity, or maybe the magic, is in the conversion process.
The digital conversion.
Right. To guarantee that broadcast quality over 20 kilometers, the system has to digitally encode the audio signal at a 24-bit resolution. That gives you an incredible amount of dynamic range. It's far beyond any standard consumer audio.
So that 24-bit encoding, that's the safeguard. It ensures that when the signal finally arrives, the noise floor is basically zero no matter how far it traveled.
Precisely. And I see the kit uses standard RCA connectors, which is great for versatility, and it can run over either single-mode or multi-mode fiber.
And that choice of fiber type really dictates the scale, right?
It does. Multi-mode is great for, say, up to 2 kilometers. Think a big convention center or a theater complex. But if you're talking about a massive stadium, you'll need single mode to hit that 20-kilometer range.
So let's talk about the operational side. For the person actually installing this, the literature we have makes a big deal about it being completely plug and play.
Yeah, no configuration or adjusting needed. You just have these little LED lights on the front for power and to see if the hyperlink is good.
And that simplicity ties into the biggest functional advantage, I think.
The noise immunity, yes. Because it's like traveling down a piece of glass, there is absolutely zero risk of electrical interference.
So you could run this fiber right alongside high voltage power lines.
Which happens all the time in stadiums and industrial sites, and you'd get no hum, no buzz, nothing. Copper just can't do that.
Okay, so that brings us to the specs. How do the numbers back this up for, a professional broadcast engineer?
Well, they tell a pretty solid story. The signal-to-noise ratio is rated over 70 dB, which is excellent, but the spec I found most interesting was the impedance.
The 600 ohm one.
That's the one. It's not a random number. 600 ohms is a legacy broadcast standard. It means these modern fiber converters can plug directly into older, very expensive audio gear without any issues. It's all about compatibility.
And the frequency response is listed as 10 hertz to 29 kilohertz.
Yeah.
That's wider than human hearing, right?
Way wider. It's designed to capture everything, all the harmonics, the sub-bass for true uncompressed fidelity.
And you get all that quality in a tiny little box or a bigger rack mount unit, and it just works right out of the box with the power supplies included.
This whole system it really shows how digital encoding and fiber optics have become the backbone for any modern large-scale event. It solves a problem that used to take huge, heavy cables and signal boosters every few hundred meters.
So what does this mean for you? If this kit can send 8 channels of perfectly clean broadcast quality audio 20 kilometers without any interference, just stop and think for a second. Think about the massive technological leap required for the systems we use today to transmit high bandwidth, real-time 4K or even 8K video over those exact same distances. The physics of the fiber might be similar, but the sheer data density is a whole other challenge entirely.